Now let's look at some scientific testing that was done at Oak Ridge National Laboratory. And what Oak Ridge did is they took a temperature profile of about 6 different locations in the United States. And they applied this temperature profile to a wall, and the wall had a combination of concrete and foam, okay? And on some specimens, they had the foam on the inside, and on some specimens, they had the foam on the outside. And then they went through the whole cycle of summer and winter, and they assigned a mass factor to these different assemblies depending on what their nominal R value was. For example, if a wall had a nominal R value of 10 and it has a mass factor of 2, that means that the wall on an annual level is not performing like a 10, an R10, it's performing like an R20. And if a nominal R value, say, was an R20, and you had a 1.5 mass factor, that would mean that the R20 on an annual basis was performing like an R30. So what they're doing is they're going all the way through the cold winter and the hot summer, and day by day, kind of duplicating the temperatures that a wall would see in a certain location. So very interesting scientific study. Let's look at it. Okay, we've got 6 different cities: Atlanta, Denver, Miami, Minneapolis, Phoenix, and Washington, D.C. So of these, Washington, D.C., you might expect to be the least affected by mass. And of these, maybe I would think that Phoenix, because these desert climates, the temperature goes up and it goes down and it goes up and it goes down. That's the kind of climate that it benefits. Let's take a look at what type of wall works best in these climates. Well, first of all, you've got between an R13 and an R17, and the foam insulation was installed on the interior. That's the first one. And you can see that Atlanta's at 1.3, Denver's at 1.4, Miami's at 1.1, Minneapolis 1.3. They're all, in the same ballpark. This is within probably the margin of error. There's a little bit of an effect there. But when you put an R13 to 15 or 13 to 17 on the exterior, look at what happens. You've got a doubling of the R value in Atlanta, 1.8 in Denver, 2.3 in Miami, 1.5 in Minneapolis. Thermal mass, not that great in Minneapolis, 2.5 in Phoenix, 1.8 in Washington. So, then you have an R9 and an R5, again installed interior or exterior, and you see the mass factors for the exterior are always superior to the mass factors of the interior. And what this study says is that, that exterior foam insulation works way better than interior foam insulation on mass, to magnify the thermal mass effect. And that the combination of foam insulation and mass is a very powerful energy efficiency measure when used in the right climate. And not that you wouldn't use foam insulation in a cold climate like Minneapolis, but in Miami, you're actually going to get more bang for the buck than you get in Minneapolis, because it's going to save so much on air conditioning costs. The kind of construction that we're talking about is, first of all, this insulated concrete forms. These 2 pictures here are insulated concrete forms. become very popular in some areas. I'll tell you, if I was building in Phoenix or if I was building in California, most places in California, or Miami, or down south, any place in the sunny south, I would use insulated concrete forms. I think that they're great. Insulated concrete forms plus a cool roof, a white roof, even a masonry roof, you know, where you can use these insulated concrete forms to form a roof structure also besides walls. Boy, there's going to be no comparison between a stick-built house and an insulated concrete foam house in the warmer climates, sunnier climates. You know, in other places in the world, this block is built in China. You have 6 inches of foam between 2 pieces of concrete in a block that you build into a block wall. I think that this would work very, very well. You'd see the same kinds of mass factors that you see here, but this is a real winner here. The Europeans build with a lot of these clay blocks, and they especially like now these energy efficient clay blocks that have a whole lot of channels inside of them. They actually have some pretty good R values in there in addition to having a lot of thermal mass. You go to a place like, you know, you go to Italy or France or, you know, all over Europe, they build with this clay block. And you put the foam insulation on the outside and you have a clay block wall like this, and boy, you really have a great building assembly for a climate like Spain, Portugal, Italy, Greece, Albania, those types of climates. I mean, those people are so tolerant to heat and cold anyways. You build a building like this and nobody would require any heating or cooling. Okay, thermal mass can work all by itself, especially in climates that are mild climates. For example, if you go to Santa Fe, New Mexico, there's a big church in the middle of a square down there, and you can go into that church on a 100-degree day and it feels, you know, very cool, very comfortable. It's all about the thermal mass. It is so heavy that it stores heat and cooling, you know, over an annual basis. But in the same kind of building, when I lived in the Czech Republic, I lived in a building that was very, very massive, and it stored heat from season to season, which meant that we were all the way into November before we had to even turn on our heating system. But on the other end of the season, into March, April, May, it seemed like the building just did not heat up until the middle of the summer. So in a climate like Prague in the Czech Republic that's at, I don't know, 55 degrees north latitude or something like that, or places in Germany, you know, Minnesota, the whole northern United States, thermal mass by itself just doesn't work. But when you insulate it, it works considerably better. But where it really pays off in places like Miami, Phoenix, Denver, California, the whole sunny South, Texas, the combination of foam insulation on the outside of the building and thermal mass makes for a very energy efficient building.